Today, we're focusing on mastering the cost approach in real estate valuation. This method estimates the value of a property by looking closely at three core inputs: the value of the land, the cost to construct the building, and the depreciation that reduces the property's overall worth. Understanding how these elements interact is essential for accurately assessing property value from a cost perspective. Let's dive deeper into each of these components to see how they contribute to the final estimate. The cost approach to real estate valuation is centered around figuring out what it would cost to rebuild the property from scratch today. Essentially, we start with the current replacement cost of the buildings or improvements, then subtract any depreciation to account for wear and tear or aging. Finally, we add the land value to arrive at the overall property value. This method is particularly handy when there aren't many comparable sales available or when the property improvements are relatively new. The calculation relies on three key inputs: the value of the land, the cost to replace the improvements, and the amount of depreciation. Here, we're looking at the valuation framework, which is built around three main appraisal approaches. Each of these methods gives us a way to determine value, but from a different perspective. First, the sales comparison approach, which is market-driven and relies on recent sales of similar properties to estimate value. Then we have the cost approach, which is our focus in this lesson. This method calculates value by adding the land value to the replacement cost of the property and then subtracting any depreciation. Lastly, the income approach focuses on property's ability to generate income, making it investment-driven. Understanding these core methods helps us grasp how value can be measured in different ways depending on the context. Let's talk about the strategic relevance of the cost approach. This method is especially important when market evidence is limited or the asset in question is newly built. It's a high-clarity valuation technique that provides a solid framework for understanding value. The cost approach adds value primarily for new construction projects or when recent improvements have been made. In these scenarios, the replacement cost can be accurately measured and depreciation tends to be minimal, which makes the valuation more reliable. It's particularly useful when comparable sales data is weak or unavailable. For special use or uncommon properties, for example, there often isn't enough market data to rely solely on comparisons. In these cases, the cost approach grounds value in tangible, objective inputs like land value, construction costs, and depreciation. This method creates a transparent logic chain that helps to justify the estimate clearly. For developers and lenders, the cost approach serves as a critical check, assessing whether the project's value makes sense compared to what it would cost to rebuild it today. This helps ensure the value is realistic and defensible. Let's take a closer look at the cost approach framework and its three essential components. First, we start with a land value, which represents the value of the site as if it were vacant. This is what the land alone would sell for in today's market, separate from any improvements. Next, we consider the replacement cost, which is the current cost to build an equivalent structure. This reflects what it would cost right now to construct the same type of improvement on the site. Finally, we account for depreciation. This is a deduction for all the accrued loss in value due to wear and tear, design issues, or external factors that reduce the overall value of the improvement. When we combine these inputs, the basic valuation logic is simple. We add the land value and the replacement cost of the improvements and then subtract depreciation. This approach gives us a grounded estimate of value based on tangible costs and adjustments. One key principle in appraisal is that land is always priced based on its highest and best use, not on the structure that currently sits on it. When we talk about the cost approach, land value is the starting point. Appraisers first value the site as if it were vacant, ignoring any buildings or improvements. They use recent comparable land sales and take into account factors like zoning, location, size, and utility to estimate what the land alone would sell for today. It's important to value the parcel independent of the existing building. Variables like location, permitted use, frontage, access, and lot size are the main drivers of land price. This method ensures that the land is accurately valued based on its potential rather than its current use. Here we focus on the cost approach to property valuation, specifically calculating replacement cost. The idea is to estimate what it would cost to build the same structure today, using current materials, labor, and construction standards, ensuring equal utility. We start with the building cost per square foot, which is $185 in this example. This figure is based on the current local construction benchmark and represents the average cost to construct 1 square foot of building space. Next, we multiply this unit cost by the total square footage of the building, which is 12,000 square feet here. When we multiply $185 by 12,000, we arrive at a replacement cost new of $2,220,000. This number represents the estimated cost of rebuilding the entire structure from scratch before accounting for depreciation and land value. It's important to include all relevant costs in this estimate, such as materials, labor, contractor overhead, and indirect costs. Once we have this replacement cost new, the next step is to subtract depreciation to reflect the building's current condition, then add the land value to arrive at a final property value. In summary, the formula is straightforward. Multiply the unit construction cost by the total area to get the replacement cost new. This forms a foundation for adjusting depreciation and considering land, which together give a comprehensive valuation. Now, let's dive into the cost approach and why depreciation is such a critical factor in determining value. Depreciation basically measures a loss in value of a property from its original cost to what it's actually worth today. The higher the depreciation, the lower the value of the improvements. There are 3 main types of depreciation to keep in mind. First, physical depreciation, which comes from wear and tear due to age, regular use, weather conditions, or even deferred maintenance. It's the most visible form of aging in a property. Second, functional obsolescence. This happens when a property loses value because of poor design, outdated layouts, or features that are no longer efficient or desirable. Third, external obsolescence. This type stems from external factors, like being in a less desirable location, heavy traffic nearby, or general decline in the surrounding market. Understanding these types of depreciation is essential because they explain why the value of improvements often falls short of the cost to build them new. It's this gap, the visible age and its impact, that really matters when we assess value using the cost approach. When we talk about depreciation analysis in the cost approach, it's important to understand that depreciation accounts for all causes of lost value, not just the property's age. Essentially, depreciation breaks down into 3 main categories, each reducing the value of the improvements in a different way. First, we have physical deterioration. This is the wear and tear that comes from age, use, weather, and deferred maintenance. Think about things like a roof that's past its prime, worn finishes, aging systems, and the overall structural condition. This loss reflects the current condition and how much useful life remains. Next is functional obsolescence. This type of depreciation happens when a property's design or layout is outdated or no longer meets market demands. It's about inefficiencies within the property itself. Maybe the floor plan is awkward or it lacks modern features that buyers now expect. These factors reduce the property's value because they don't function as well as more up-to-date designs. Finally, we have external obsolescence, which comes from factors outside the property's boundaries. These could be zoning challenges, increased traffic, nearby nuisances, or generally weaker market conditions. Since these are external forces, they affect the value but are beyond the owner's control. Understanding these 3 categories helps us see how different sources of depreciation contribute to the overall loss in a property's improvement value. This comprehensive view allows for a more accurate and realistic appraisal. Let's walk through the cost approach step by step. The key to this method is building value in a clear, logical sequence. First, we start by estimating the land value as if it were vacant. That's step 1. Next, in step 2, we calculate the replacement cost new for any improvements or buildings on the land. Moving to step 3, we measure total depreciation, which includes all factors that might reduce the value, like physical wear or functional obsolescence. Then, in step 4, we subtract that depreciation from the replacement cost to arrive at the depreciated value of the improvements. Finally, step 5 involves adding the land value back to this depreciated improvement value, which gives us the indicated property value. Keeping this sequence ensures accuracy and clarity throughout the valuation process. The formula to remember here is land value plus replacement cost minus depreciation equals the property value. Here we have a real-world example illustrating the cost approach to valuing a suburban office condo. The property is 2,400 square feet, built in 2016, and in good condition, representing a typical asset in the secondary market. Let's break down the valuation step by step. First, the land is valued at $180,000. Next, the replacement cost new for the building itself is $420,000. We apply 15% depreciation to account for wear and aging, which reduces the building's value by $63,000. So, when we subtract depreciation, the depreciated improvement value comes to $357,000. Adding the land value and the depreciated improvement value gives us a total indicated value of $537,000. This is compared against an observed sale comparable, which closed at $530,000 after 41 days on the market, showing a tight alignment. The slight difference of 1.3% highlights how close the cost approach estimate is to the actual sale price, reinforcing its reliability in this scenario. So, this example demonstrates that by considering land value, replacement costs, and depreciation, we can arrive at a credible estimate of a property's worth in the current market. Let's go over some common pitfalls to avoid in the cost approach to valuation. First, using outdated construction costs can really throw off your estimates. Material, labor, and contractor prices can change quickly depending on the market and the type of project, so it's crucial to use the most current data. Second, overestimating the land contribution is a big mistake. The site value should be based on actual local land sales, not on assumptions tied to prices of improved properties. This helps ensure your valuation is grounded in reality. Third, ignoring functional or external depreciation can lead to significant errors. Physical wear is just one aspect. Issues like poor layout or market obsolescence can also reduce value significantly and must be factored in. Finally, skipping local code and quality adjustments is risky. Replacement costs need to reflect current building standards, compliance requirements, and a specific class of building being evaluated. Remember, small errors in these areas, land value, costs, and depreciation, can compound quickly, distorting the overall value. Being aware of these four common errors can help you avoid costly mistakes and produce a more accurate valuation. Now, let's talk about the application scenarios for the cost approach and when it's most effective to use it. This method works best in situations where the cost to build or replace the property is clear, depreciation can be accurately measured, and there aren't many comparable sales to rely on. There are three main scenarios where the cost approach adds the most value. First, with new construction, since the improvements are recent, estimating replacement cost is straightforward and depreciation is minimal. Plus, cost data in these cases tends to closely reflect the current market reality. Second, when dealing with specialized properties like schools, churches, or other unique buildings, this approach is particularly useful because comparable sales can be rare or inconsistent. Here, the sales comparison method might not provide reliable insights, so the cost approach fills that gap. Third, in markets where evidence from recent sales is limited or insufficient, the cost approach serves as a reliable support method. It provides a strong check against other valuation techniques, ensuring we have a well-rounded view of the property's value. Overall, the cost approach shines in high-confidence scenarios where it complements or strengthens the valuation process. Let's wrap up by focusing on the essence of real estate math. The key to mastering valuation is to master the inputs. When we measure land value, replacement costs, and depreciation with discipline, the cost approach transforms from a rough estimate into a precise and reliable decision-making tool. Think of it this way. There are three critical components, land, cost, and depreciation, but only one valuation logic tying them together. We start with land, understanding exactly what the site itself contributes. Then, we move to cost, carefully estimating today's replacement cost with rigor and accuracy. Finally, we adjust for depreciation, accounting for the effects of time, wherein obsolescence. This method prioritizes precision over guesswork, ensuring that every valuation is grounded in solid data and thoughtful analysis. This, in essence, is your final takeaway from mastering real estate math.